high. Suppose x is a normally distributed stochastic variable with expected value mu and variance sigma squared as usual. I've drawn the graph of the probability density function of x. So it's symmetric about x equal to mu. And I've shaded an area of 0.7. And the question is, what is the x value here? So that the cumulative probability of x being less than or equal to this minus x is exactly 0.7. And we have a command on the calculator which gives this x value, and it's the inv norm command under the distribution menu. So I'll show you how to use it. So as you can see, you take the distribution menu, second distribution. Choice number 3 is inv norm. And you can simply put 0.7, and that gives you a number 0.5244 and so on. So that number gives the z-score of x. So z-score of x is 0.524 approximately. That means that x is mu plus 0.524 sigma. And now another example. X is normally distributed with known expected value of 60 and known variance of 4. That means the standard deviation would be 2. We're given the probability of x being less than or equal to small x, and that's 0.3, and we want this value of small x. So graphically, we have 60 here, and we have a normally distributed variable with mean 60 and standard deviation 4. And we want to find the x value so that the shaded area here is exactly 0.3. And again, we use the inverse distribution, and I'll show you on the calculator. So what you do is you take inv norm, and with the inv norm you choose 0.3, but you could also give mu and sigma for this one. So we give mu and sigma, and that gives us 58.95. And that's x. We could also go via the standard deviation, the standard normal distribution. If we had just taken inv norm of 0.3, that would give us the z-score of x. And to actually find x, we should take mu plus the z-score, which is now in the answer variable, times the standard deviation. So as you can see, it's the same answers. Yeah. Let's take an exercise. It's from section 15.5 or 17.5. 17.5 in higher level, 15.5 in standard level, and it's exercise 10 in both books. So x is normally distributed with expected value mu and unknown variance sigma squared. And we want to find sigma, the standard deviation. We're given additional information. The probability that x is less than 16.56 is 64%. And this is an instance where we need standard normal distribution. So what we can do is we can find the z-score of 16.56 because we know the probability of being less than this value is 64%. So we can find the z-score of this one. And if we have the z-score, the value, and the mean, we can put up an equation and solve for sigma. Let's see how that goes. So let's compute the z-score of 16.56. So we go here and distribution, inverse normal, and 0.64, which is 64%. And we get 35.8%. Approximately. So that's the z-score. And I'm going to store this number to the variable z. Now, z is the expected value mu. The formula is x minus mu divided by sigma. And x is the observation, 16.56. Mu is 16, and I divide by sigma. So I divide by the unknown. So that means I can multiply by sigma and divide by z. So I get sigma equals, well, this difference is 0.56 divided by z. And that is approximately 0.56 divided by z. 1.56.